Hello, my name is Andrew Carroll, and I am the current transit operator for the archaeological excavations at Poggio Civitate, Merlot in Tuscany, Italy. And today I'm going to be talking about some of the basics behind the transit and its operations and its use at our site. Before I go on, I would like to thank a couple people. First, John Lannon, a former site architect who taught me how to use the transit. And then Andrea Rodriguez for putting up as I frolicked off into the woods to go and learn how to use this lovely device. So sometimes in transiting can feel a little bit like this, that you're making up numbers and that points really don't matter. Well, that's not totally true. The transit is very helpful in creating a grid that allows for relative but quantifiable measurements. And then it allows these relative measurements to be compared to each other when you connect them to the master grid, which we established in 1991. And we'll talk more about the master grid later on in this PowerPoint. One thing people think the transit is a GIS program, and it's not. This transit has nothing to do with latitude and longitude. It is all relative grids, is what we are using it for. So the transit is basically a baby of the telescope and a compass. You have the telescope to kind of give you take your lines of sight, and you have the compass to record quantifiable degrees when you're doing your work. Now, because it does have this telescope on here, you need to have a clear line of sight when using the transit. Otherwise, all the little branches that are on the side of a path will be magnified, and it'll be very hard to kind of get an accurate reading. So it's always good to have a good pair of clippers with you, and it's great if you can have some other people walk the line of sight you're trying to place, so that you can kind of use them as a relative tool to see what branches need to be cut down, and then they can do it for you, which is also helpful. In 2011, the line from two permanent points on our hill, PC1 and PC6, was cleared back further than needed. And this was because the excavations were delayed a little that year, and this allowed for us to have very good lines of sight for that year and to have less clearing to do in future years. So if you ever have a chance and there's overgrowth on some of the common paths that we are using, it's always helpful to kind of cut back and trim back all those vines that grow. Now, the master grid, as I said before, was established in 1991, and this is a little late. We started excavations in 1966, and so you're probably wondering what went on in there. Well, the earlier trench books used a local grid system, and they did this because they thought the excavation was going to be short term. At the time, they only knew about a single phase, the archaic period, and also it was totally accepted at that time to do that type of local grids. Now, this does create some troubles because these local grids are not always connected to one another. That's why we have developed this master grid. And we have to, in 2004, we have Teresa, Javon, Haley, and a bunch of others to thank for working out an algorithm to kind of plot these earlier trenches. So what this means is many trenches before 1991 have coordinates that are not whole numbers, while trenches after 1991 have, for the most part, whole number coordinates. Now, most of the recent trench books will mention Tony Tuck #1, a trench book written by Dr. Tuck, and give a brief summary about the master grid. However, if you're looking for a fuller summary of the master grid and what they did, you can obviously read Tony Tuck #1 for all that information. So you can think of the master grid as a giant math grid placed on the hill. I know everyone loves math. The 0y and the 0x point is the metal pole placed near the archaic well. That's known as PC1. And with this whole chart, we get positive and negative numbers out of it. So whenever you are dealing with positive numbers, you're either dealing with north or east points. Whenever you're dealing with negative numbers, you're dealing with south and west points. This kind of gives you an idea when you're looking through the catalog of where relative on the hill you may be looking. So here's a site plan, the 2011 site plan of Poggio Civitate, for the most part. And right there where the arrow just swooped to is the PC1, is the 0 point. These are the excavation units that we were working in 2012 and probably in 2013. So right along the road. So basically, if you connect these two arrows, kind of like this is roughly where the road runs down. And so this is basically what you have to envision the master grid as being. It's a series of grid lines, a meter wide, running across the hill. And then you can subdivide it into centimeters and then millimeters if need be. Now, this is archaeology, not H-bomb manufacturing. It's okay to not be totally accurate. Plus or minus 10 centimeters is considered very accurate when dealing with these things. So sometimes people will get frustrated, myself included, when the transit seems off, and you got to remember it's archaeology. Having a little bit of movement is okay for what we're dealing with here. We're trying to create a relative system, and as long as we can recreate that, then we're fine. When using the transit, make sure you write down everything you do. This is for two reasons. One, you can figure out and or catch mistakes about what you're working on. And also other people can come back and see what you did and probably curse you for it, but at least they can see what you did and reconstruct your thought process. And then when you're writing down everything, this means you're writing down what the weather was that day, because the heat waves will affect the accuracy of the telescope, the people who are helping you, so that they might be referenced later on and can be asked questions if you're not around, the points you used, the measurements you took, and any calculations that you made, where you placed points, any trenches that you established, and any relative objects to kind of help allow people a rough idea of where you were without using a transit. So mentioning a rock or the road or an old trench or those things to kind of allow people to envision this without having to pull out the transit and walk and do all the math themselves. When you're using the transit, always double check your measurements, always double check your calculations, always double check the knobs on the transit, that they're locked when they're supposed to be and unlocked when they're supposed to be, that the thing's level. Make sure that you're adding correctly or subtracting when you need to. Make sure that the measurements, they're not being tangled in brush and the tape's off by a couple of meters because it's caught up on something. Always double check. It is better to, they always say it, measure twice, cut once. Well, cutting a trench, it's kind of hard to cut again, so it's definitely important when dealing with the transit to always double check everything. So, setting up a transit. Now, the next couple of slides are all about things that you can do with the transit, and I should say that nothing beats actually doing this in the field, but this will give you an idea of what's going on. So first thing is you set up the tripod with a plumb bob attached to it, and you can see that here, and you can see the top of the plumb bob string right here. Then you attach the transit head, which is this item right here. That's the actual working part of the object, and level it with these 3 black knobs. And when you're leveling it, you want to make sure that you are doing little adjustments, so you don't need to crank on them because you don't want to have the thing be too wonky. Oh, and I should mention that the plumb bob is used to allow a more accurate measurement for centering the transit head over a known point of some kind. All right. The next thing you're going to do is you're going to line up the degree plate, which is the compass, and the eyepiece. And the eyepiece is this thing right here. And there are 2 degree plates in there, and this is called zeroing it out. And you will see hash marks with numbers on it, and you want to get the zeros over each other. And then if you happen to be shooting a data points, the datums around the site, then you will level the eyepiece. If you're not shooting data, no need to worry about it. Now, you want to be gentle with all the knobs and the screws because they've become loose with many, many years of use and many years of people cranking on them or turning them when they're not supposed to be turned. So you want to watch out and make sure that you're not being rough with this with this piece of equipment. It works better if you're gentle. That's all I have to say. All right, so a common thing we do is make baselines, and it's basically creating those imaginary lines that of the master grid, actually creating physical lines for our work. So we are allowed can set up the trenches. So typically we set up the transit over a known point, either the metal pins that are around the hill or a nail that you have placed. Don't use old nails because they've probably been knocked out. And then you end up sending a second person to another known point with a rod and have them hold it perpendicular over that point. You line up the crosshairs in the eyepiece with the center of the rod, and now your transit head should be lined up with a line on the master grid. At this point, you end up locking the degree plate and the eyepiece together. And now you can leave the degree plate locked and unlock the eyepiece, and this allows you to turn it without the compass being moved around. It allows you to turn the eyepiece and place lines wherever you need them to be. Typically, we deal with right angles at our site, and so you can turn the eyepiece at a right angle and using a tape measure, place a nail a known number of meters from the transit by using the crosshairs of the eyepiece. Now, I say we use right angles, and that's just because we like to keep it simple. We could do trig, but it's more complicated, not as easy in the field, and there's more room for error. So it's easier just dealing with the right angles here. Also, the fact that we have a master grid makes that whole process a lot easier too. So you can see here, John Lannon looking in the eyepiece, and Miko is holding the rod on another known point. In this, John's creating a straight line lined up with the master grid. Now, shooting datum points. Again, you set up the transit and level it, and you measure the height of the transit to the center of the crosshairs. And you then add this height to a known absolute height. PC1 and PC6 both have known and recorded heights. The other metal points around the hill have known heights as well, but you have to dig through some numbers. Then after you know this absolute height, you swing the eyepiece around to a sturdy object, typically a tree, into which you can place a nail, and you place that nail at the center of the crosshairs. This means that the nail is the same height as the transit, and ergo they're the same absolute height. Now, these absolute heights are another kind of arbitrary measurement on the hill. It's some random point in the middle of the hill that we just said was the 0 point, and we've, counted up from there. They do not connect to contour lines or sea level measurements, although if we wanted to in the future, we can connect them to that. Now, when placing the nail, you of course can use a tape measure to adjust the height up or down to your liking. One of our former excavation unit supervisors liked to have whole numbers for his datum, and so we would place the nail and then using a tape measure, count up or down depending on what we needed. All right, so some final comments about the transit. Like I said before, nothing beats field practice. These concepts are just that. They're just concepts for you to kind of think about and to kind of get an idea of what you're going on through, but you're going to have to actually do it to understand and fully get this. Also, all of this can be done with a total station, but you are a better person for doing it the old-fashioned way, and you also gain an appreciation for the work a total station can do. Sometimes you may bang your head, I may bang my head against the wall, saying, why am I doing it this old-fashioned way? And you know what, it is a better way to do about it because it allows you to think about these things. And heck, archaeologists were doing this for hundreds of years before with the transit. Actually, the Romans were even using transits well before any total station. So if they can do it, we can do it. Make sure you write down everything so that future archaeologists can figure out where our trenches were. Like I said before, on an earlier slide, writing down all sorts of information, even if you think it's silly at the time and other people think it's silly that you're doing that much work, it is much better that you leave this record so that other people can figure it out than have partial records and then people are like, well, this seems screwed up. Well, how did this happen? Write it all down. Don't drop the transit. Be very careful. Be very gentle with it. It is a There's a lot of glass in there. You don't want to shatter any of it. And then don't worry. We all screw up. Just try to fix it when you figure it out. Try to ask someone for help when you figure it out. If you figure out your screw up on your own, try to fix it quietly if possible. But don't worry. This is not heart surgery. This is not manufacturing any type of atomic weapons. It's archaeology. There's a little forgiveness in mistakes. So don't try and hide it. Try and figure out how to fix it, and then go ahead and fix it. All right, I hope that's been helpful. I hope to see you all in the field soon, and have a great day.